Okay, in this problem we have the situation that one student is selected at random from a group of 200 students. The group consists of 140 full-time, from which 80 are female and 60 are male students, and 60 part-time, 40 female and 20 male. Everything that is said above is illustrated in the table. All what you have to do now is to complete the totals in the table. So, for example, how many females do we have? It means that you are looking at this here. So 80 plus 40 is 120. How many males do we have? It means that you add these two numbers, 60 plus 20 is 80. And of course, the total sum should be 200. Now, let's ask how many full-timers do we have? Full-time is this column here, which is 80 plus 60. This will be 140. And how many part-timers do we have, which is this column? 40 plus 20 is 60. And notice also that 140 plus 60 is going to give you also 200. Okay. Now remember this table. We will use it to solve the questions. But first, they are giving us symbols for events. So let F mean the event female, M mean male, A mean full-time, and B mean the event of a part-time student. Okay? Just remember these. They make it easy for you that they write them already on the table here, so you remember what each one of them mean. It's just a shortcut for, instead of saying full-time, you just say event A. Instead of part-time, event B. Instead of female, you just say F. Okay, so let's solve. We have two sub-questions here, 1 and 2. Let's solve them each on a separate page. So the first question is, are the events A and F independent? Remember, what is the event A? A is full-time, and F means female. Are they independent? Well, if you understand tables, immediately you can tell they are not, because there is an intersection. There are female that are also full-time. But if you want to prove it using the rules that we have, you can compare. So when are events independent? Independent means that the probability of A and F should be the same as the probability of A times the probability of F. So is this the case? We put a question mark here. If it's true, then they are independent. But if the numbers are different, if they're not equal, then they are dependent events. They will be not independent. So first, what is probability of A? Let's do probability of A. Probability of full-time. We have 100 full-timers out of 200 people. So it's 140 out of 200, and this is exactly 0.7. Now, what's the probability of female? Probability of female, we have 120 females out of 200 people. So this will be 120 out of 200 people, and this is exactly 0.6. Keep those numbers in mind. So therefore, remember that we are checking this. We are checking this. And okay, so you have two things. If they are really equal, then independent. If they are not equal, the two numbers, then this means that the events are dependent on each other. So let's compute probability of A times probability of F. The multiplication of the two will be 0.7 times 0.6, and this will be 0.42. So 42%. This is one of the two numbers that we want to calculate. You see, this is the product of the two turned out to be this. Now, all what we're left to do is to check the probability of A and F, full-time and female. Now, probability of full-time and female is equal to, if you look at the table, this means full-time and female are 80 out of the total, which is 200. So this is 80 divided by 200, and 80 divided by 200 is actually 0.4 exactly. So now this number is the number that we have here. So in other words, you can see that the two numbers that we have, one of them is 0.4, the other is 0.42. So notice that these two numbers are not equal. So you can say, therefore, probability of A and F, so full-time and female, is not the same as the product of the probabilities, probability of A times probability of F, and since they are not equal, this means that the events A and F are not independent. Or you can say, instead of saying not independent, you can just say dependent. So we have seen now that these two events, A and F, are dependent. So if you want, it means that the answer to this question is a big no. They are not independent, they are dependent. Let's go to the next one. In this one, we need to compute the probability of A or F. But they're asking you to use the multiplication rule, which I believe it means for the AND, because there is an intersection. You know that they are dependent events. So the probability of A or F, you remember the rule, it says it's the sum of the probabilities, probability of A plus probability of F minus the probability of A and F. And this is equal to, so before we continue, I want you to know something about this. Because they asked us to use the multiplication rule, and we know that these two events from the previous one are dependent, this must equal to the probability of A times the probability of female given full-time, given A. Okay, because they are dependent events. That's how the multiplication rule works in this case. And this is 140 out of 200, okay, times probability of female given full-time. If you are given that you are full-time, how many females do we have? 80 out of the full-timers, 140. So this becomes 80 out of 140. And because we're multiplying, you can cancel these two, and the answer will be 0.4. As we did in the previous one, but here I'm showing you how to use the multiplication rule to do it. Okay, I'll put it in this color. Okay, and now remember, probability of A, we computed it, it was 0.7. Look at the previous one. Plus probability of female, we computed it in the previous one, it was 0.6. Minus, we used the multiplication rule to find the probability of A and F, and we got 0.4. And so if you do 0.7 plus 0.6 is 1.3 minus 0.4, you'll get 0.9, which is the same as 90%, which is 90%. And so this is the probability of OR. And when they tell you to use the multiplication rule, they mean for the AND, this one, the AND, since they are dependent events, as we saw here, we saw that A and F were dependent. This is why we use this rule of the conditional probability for the intersection. And then we get, of course, the same answer, 0.4, as we got in the previous one when we computed it here, if you remember. we computed it directly from the table, as just we saw full-time and female are 80 out of the total 200, and so 80 out of 200 was 0.4. And in this question, we did the same thing for the computation, but using a different formula. I mean, we got the same answer, but using kind of a different formula, even though it's the same. At the end, it was the same, because this 140 cancelled with the 140, and so we still got 80 over 200 that you could see here, 80 over 200. It's the same, actually. And this ends this question.